Hi everyone, this is Sharan. Welcome to my channel. Today we are going to see about Z statistics or Z-test. So before going into the details, let me tell you what would be the various scenarios when we can use the Z-test. So as you see here, so we can use Z-test when the number of samples is greater than 30. So this is based on the assumption from the central limit theorem that the larger the sample that we have, it is more likely to become a normally distributed data. So in order to do the Z-test, we need to ensure that the data is normally distributed. So we ensure that by considering a larger sample, and we need to ensure that the standard deviation is known. So we need to ensure the standard deviation of the population is known. In many cases, we might not be very sure about the standard deviation of the population. But what we assume that this is a larger sample. The sample that we are having is large, and we assume that the sample standard deviation is approximately equal to the population standard deviation whenever the population standard deviation is not known. And the samples that are being picked up from the population should be random. So these are all the various requirements for us to proceed using the Z statistic or Z test. So now having said that, what should be the consideration in order to perform the Z-test, the next test is what are all the different types of Z-test or Z-statistics. So these are all the various types. So it's one sample, two sample and paired Z-test, and all of them can be classified into one-tailed or two-tailed. So we will be going through the examples for each one of them to explain how it differs and when to use what kind of a test. And the formula for one sample and two sample can be found here. So where the H bar is the sample mean and then mu is the population's mean, and then if you go to the denominator, the sigma is the population standard deviation, whereas the n is equal to the size of the sample, the number of the samples that we have. So this will be used in case of one sample Z-test, and when we have two sample Z-test, the formula slightly differs. If you see here, H1 bar and H2 bar are the samples mean. So here in case of two sample Z-test, we have two samples. So H1 and H2 are sample 1 and sample 2. Similarly, mu1 and mu2 here are the population's mean for population 1 as well as the population 2 that we are considering. So we will go into the details, like what exactly the two sample test is, and then you would understand what is mu1 and what is mu2. And in the denominator, similarly, sigma 1 is the standard deviation of population 1, sigma 2 is standard deviation of the population 2, and n is the size of those populations. So having said that, so these are all the formula for one sample Z-test and two sample Z-test, and we know when to use Z-test. Like based on this, we know that the standard deviation of the population should be known. So even if we don't know the standard deviation of the population, so we should be able to get the standard deviation for the sample, so which we can approximate, we can take it as approximately same as the standard deviation of the population. And we have seen about the different types and what's the formula for one sample as well as two sample Z-test. Okay, so now let's go into the examples and understand each one of them. Like when can we use one sample Z-test, or when can we use two sample Z-test or a paired Z-test. So coming to the first example, like as you see here, so what we are saying is we are saying that there is a company A which claims that the products that are sold on their platform tend to sell more. So this is what their claim is. So now, what kind of Z-test can we use in order to prove this hypothesis or reject this hypothesis? So here what we are saying is, we are saying that there is one company which claims that the products sold on their platform has higher probability of selling, or like they're more likely to sell to more people. So this is what an company is saying. So what we can do is, this can be considered as a sample. Like company A is a sample which claims that the products sold on their platform are more likely to sell more as compared to a normal. So as compared to the population. So here what we are doing is we are comparing a sample, company A's data, with that of the whole population, where in general the products sold maybe in all other platforms put together, and we are comparing it with the products sold on a particular platform, which is company A. So here, since we are comparing a sample with the population, so here what we need to use is we need to use the one sample Z-test. Of course, some of the criteria that should be considered here is whatever sample that we are considering here. Let's say company A claims, so then if the company A claims that more likely to sell more, so then let's say if we are comparing the data on day wise, the products sold on a day level, so then we need to have enough samples, like we need to have at least like 30 or more days of data, and we need to know the standard deviation of the population, or at least the standard deviation of the sample, which we can maybe use it for the population in the formula. So here, so we have clearly mentioned that the company A claims that product listed on their platform have higher sales rate. So now what we have is we have some data, right? Mean products sold on company A per day is 150. So let's say mean of particular product, like maybe a phone, or it could be anything that sold on company A per day is 150. Whereas this particular product, like the same phone, in general, it sells on an average of 130 products per day with a standard deviation of 18. So then what we can do is, based on all these data, all these three data points, what we can do is we can apply this particular formula here. So where X bar would be the mean of products sold on company A per day, which is 150. So here we say 150 minus 130 divided by standard deviation. We don't have the standard deviation of the population, so we take the standard deviation of the sample, which is 18. So 18 divided by the root of number of samples that we consider, that depending upon the number of days of data that we have. So we use it, and then we can apply this particular formula in order to get the Z value, and then we use the Z table to see if it is significant or not. So as explained in the hypothesis testing, which was in the previous session, so in general the probability value cutoff will be like 0.05. So depending upon that, we can see whether the null hypothesis, which will be there is no difference between the sample and the population, whether the null hypothesis can be accepted or rejected. So this will be decided based on the final p-value. So this is an example of one sample Z-test. So here I will explain again. So here it is one sample Z-test because we have only company A's data, so which is a sample, and then we compare this with the whole population. So in general, what's happening? So maybe if we can come up with a new example. So let's say there is an institute which claims that people who study in that particular institute are more likely to succeed, or more likely to maybe earn more. So then what we can do is we take this particular institute's data, we see what is the average salary earned by the people who passed out of this institute, and then we can compare this with the general population and then see if there is significant difference. And then if there is significant difference, then we can say that the null hypothesis is rejected, which is there is some difference between people who pass out of this particular institute and others in general. So again here we compare the data of one particular institute and then compare it with the actual population. So here this is also one sample t-test. So this can be applied to any number of example. Let's say a particular drug was given to a small set of people, and the others are not given those drugs, and then people who have given this particular drug, do they have any significant change? Maybe, so if it is performance related one, whether there is any significant change in their level of performance or whatever it may be. So here, so this is the one sample t-test that we have covered here. So for all these three cases, it can be either one-tailed or two-tailed. So what is this one-tailed or two-tailed? So in our example, what we are saying is we are saying that the platform A have an higher sales rate. So here we are clearly saying that it has a higher sales rate. We are not saying that the sales rate will be different. So when we say the sales rate will be different, it means that it could be positive or it could be negative. So which means that when we have a bell curve like this, it could be on the either end. So when there is a possibility for it to be on the either end, so then it is two-tailed. So when we reject, like, or when we ignore one of the sides, and then let's say in this example we say that it will be higher, so it is an one-tailed test. So we are not worried about the other side, we are worried only about the side, like with the higher side. So that's the one-tailed. So yeah, so that's about the one sample z-test as well as one-tailed or two-tailed test. The second one is two sample z-test. So here in this case, what we are going to do is we are going to compare two different samples. So here in this case, we had only company A's data. So let's say we have company A and company B. So here we are not making any comparison to the actual population. So we are comparing company A's sales with company B's sales. So we are seeing if there is any significant difference between the sales of these two companies, or maybe if we want to go with an one-tailed test, so it could be something like checking whether company A's sales is better than company B's sales on a daily level for any particular product. So then in those cases, what we use is we use two sample z-test. So we have two different samples and then we are comparing the mean of those two different samples. Of course, even in this case, we need to know the standard deviation of the population. So when we say company A and company B, so for this particular experiment, we will be considering a smaller sample, let's say a few days of data, but we would need to know about the standard deviation of the population. So even if we don't have the standard deviation of the population, since in these z-test, the sample size should be at least 30 or more, we take the sample's standard deviation and then we approximate that, we consider it as the population standard deviation. So in case of this particular example, like when we compare it with two samples, we use this particular formula here. So if we can translate this into different examples, let's say the institute comparison that we were doing. So let's say we have two institutes, Institute A and Institute B. Like which institute, like students studying in which institute are more likely to be successful in their career. So then in those cases, again, we use two sample z-test, or maybe let's say there is drug A and drug B. So which drug is more likely to be successful? So in those cases, when we have two different samples, two different specific scenarios that we are going to compare, so then we use two sample z-test. The last one is paired z-test. So coming to the example here. So here what we are doing is we are considering the same example. Let's say if we consider company A's data. So we consider company A's data, but what we do is we use before and after. So let's say company A is trying to introduce a new feature. So what was happening before introduction of the feature, like number of products sold before introduction of this particular feature and after introduction of this particular feature. And so we are trying to compare like A to A, like before and after, like same products, same like before and after introduction of something new into that particular sample. So in those cases, what we do is we use a paired z-test. So if we take maybe particular drug as an example, so what we can do is, let's say performance related one, or it could be anything. So then what we say is, we say like before having the drug, what was the performance of that particular sample, and after taking the drug, what was the performance of that particular sample. Or if we use like the institute data, like before coming into the institute, what was the how successful was their career, like how much they were earning, and after passing out of that particular institute, is there any difference in their earning? So comparing before and after for a same population. So then in those cases, what we use is we use paired z-test. Again, whenever we are going to use the z-test, we need to ensure that the samples are completely random and we have at least 30 or more number of samples, because we want to ensure that it is normally distributed, and then we need to ensure that the standard deviation is known. So this is all about z-test. There are various materials that are available, because like having seen this example, you should have some understanding about what z-test is, when this can be used. but I would recommend that you need to read more about ZTest. At least spend 1 hour, next 1 hour, in trying to read about ZTest, various examples and how it is being calculated or when it is being used. So I will provide some links in the description, so which you can make use to read and get familiar about ZTest. And that is it for today. I hope you have learned something new. And if you have learned something new, please give a thumbs up and subscribe to my channel if you haven't. And if you think that this might be helpful for any of your friends, please feel free to share it with them. That's it for now. See you in the next session.